Hi all, in this video I am going to explain most important MCQs in control system. Problem number 1. What is the gain of the system given below? The block diagram is given. Here I am going to find out the gain of the system. In this block diagram, there are two different combinations of blocks are available. Here this is the parallel block, and next one is this is the feedback loop. First of all, I am going to reduce the parallel block, and next I am going to reduce the feedback loop. So in a parallel block, how to reduce this? Add the gains in the parallel block. So both are combined together, we'll get the gain as 5. Now it is converted into single block. And next, this is the feedback loop. In this feedback loop, it consists of two elements, that is 12 and 1 by 4. Next, I am going to reduce the negative feedback loop. So what is the formula? G divided by 1 plus GH. G is the forward path loop gain, and 1 by 4 is the feedback loop gain. 12 divided by 1 plus 12 by 4. 12 divided by 4, that gives 3. 3 plus 1, 4. 12 by 4, that is 3. So I have to substitute the 3 here. Now it will be converted into single block. Now this block diagram consists of gains 4, 5 and 3 both are connected in series. 5 and 3 are connected in series. What is the resultant? Resultant is the multiplication of 5 into 3, that is 15. And next, this 15 and 4 both are connected in parallel. So what is the net value? 15 is positive, 4 is negative, so I will get the answer 11. So the option B is the correct answer. Next I am going to explain the problem 2. The block diagram shown in figure is to be represented as in figure B for what value of h of s. Here in this block diagram, there consists of 3 blocks, 10 by s plus 3, 1 by s and 5. Here this is the takeoff point. Here you have to multiply both, that will provide the answer 10 divided by s in the s plus 3. I am going to move the takeoff point from this to this place. Okay, if I move the takeoff point, so I have to divide this block by 1 by s. So in this way I have to move this 5 divided by 1 by s, and already this is in the loop. Okay, now the total that formed as a parallel block. How to find out the resultant value? 5 divided by 1 by s, that is 5 into s. So 5s plus 1. 5s plus 1, that is the correct answer. Option A is the correct answer. Next, a system has transfer function 2 minus s divided by 2 plus s. What is its gain at 2 radians per second? So first of all, I am going to write the transfer function given 2 minus s divided by 2 plus s. Convert this into sinusoidal transfer function by putting s is equal to j omega. So g of j omega is 2 minus j omega divided by 2 plus j omega. Next I have to take the modulus here. So square root of 2 square plus omega square. Square root of 2 square plus omega square, the value equal to 1. So option A is the correct answer. Next problem. A system has transfer function 1 minus s by 1 plus s. It is so any non-minimum phase system one of the pole or one of the zero in the right half of the S plane. Here the numerator consists of 0. So S is equal to 1. That is in the right half of the S plane. So this is the non-minimum phase system. Next problem. It is given that G of S is equal to 1 by S square into S plus 2. This system in a closed loop with unity feedback. What is the order and type of the closed loop system? What is order? Maximum power of S in the denominator. So the maximum power is here S square into S cube. So 3 is the correct answer. Then what is the type of the closed loop system? Type is pole at the origin. So how many poles at the origin? There are 2. S square, 2 poles. So 3 and 2. Option B is the correct answer. And next, the transfer function of the system K divided by S square into 1 plus St is operated in an open loop mode. The system is 2 poles are at the origin, so directly we can say the system is an unstable one. So option B is the correct answer. Next problem, the transfer function of the system K divided by S square into 1 plus St operated in a closed loop mode with unity feedback. The system is. So first of all, I am going to find out the characteristic equation because this is in a closed loop mode. So 1 plus GH equal to 0, 1 plus K divided by S square into 1 plus St equal to 0. So S square into 1 S square into S cube into T plus K divided by S square into 1 plus T equal to 0. By cross multiplying this, the denominator term completely eliminated and numerator term is 3 S cube into T S square. There is no S in K. So this system is a unstable one. So option B is the correct answer. Next, if a closed loop transfer function's damping ratio 0.5, what is the value of M? So here damping ratio is given. The damping ratio is 0.5. Theta is given. This is the block diagram which consists of 3 blocks, 1 divided by S into 1 plus 4S, MS and 100. So first consider this. This forms a closed loop, negative feedback. So G1 of S is 1 by S into 1 plus 4S divided by 1 plus MS, that is H of S into 1 by S plus 4S. Now I have to take LCM here. So S into 1 plus 4S both should be cancelled and numerator 1, denominator 4S square plus S plus MS. So 1 divided by 4S square plus M plus 1 into S. Next, here this is the resultant, that is G1 of S. So this forms one block and G1 of S and 100 both are connected in series. So multiply 100 with G1 of S. So new transfer function is created, that is G2 of S. 100 divided by 4S square in plus M plus 1 into S. Next, see here, this is the closed loop with the transfer function, forward path transfer function G1 of S and the feedback H of S is equal to 1. So what is the formula? G of S divided by 1 plus G of S into H of S. So here I have to substitute the value G of S 100 divided by 4S square plus M plus 1 into S divided by 1 plus G of S into H of S. H of S value is 1. Now I have to reduce using the LCM. So finally we get 100 by 4S square plus M plus 1 into S plus 100. Compare this with the general second order transfer function omega n square divided by s square plus 2 zeta omega n plus omega n square. Divide the 4. Here take this equation and equation is divide the equation by 4. So new equation is square plus m plus 1 by 4 plus 25 is 0. So what is omega n square? Omega n square equal to 25. What is omega? Plus or minus 5 radians per second. And 2 zeta omega n is equal to m plus 1 by 4. Now I have to substitute all the values. 2 zeta 0.5 omega n 5 equal to m plus 1 by 4. So the answer is here 5, 4 into 5, 20, m is 20 minus 1, that is 19. So 19 is the correct answer. Next, problem number 9. The type denotes the number of poles at the origin. Number of poles at the origin is the correct answer. The transfer function of the system is k by t plus s. What is the steady state error when applying u of t in the closed loop system with unity feedback? So u of t, that's a step input with unity feedback. So first of all, I am going to write the transfer function given. And what is the error? Steady state error for ramp CSS is 1 by 1 plus kp. And next, I am going to find out kp. Kp is the positional error constant. Kp equal to limit s tends to 0 g of s. So limit s tends to 0 k by t plus s. So kp equal to k by tau. And here I have to substitute the value here. 1 divided by 1 plus k by t and t divided by t plus k, that is the correct answer. So option C may be a correct answer. Next, problem number 11. For the feedback system shown in the given figure, the forward path does not affect the system output when kg is. See in the block diagram, k and g both are connected in series. So what is the resultant block? Resultant block is kg. What is the feedback element? That is h. The formula is c by r is equal to g divided by 1 plus gh. Instead of g, we are having kg. And kg divided by 1 plus kgh. That is c by r. Have to use 3 values for kg to find out the solution. First of all, kg equal to 1 and h equal to 1. What is c by r? C by r equal to 1 divided by 1 plus 1, that is 2. The first answer is 0.5. And second condition, kg equal to 10, h is equal to 1. And what is c by r? 10 divided by 1 plus 10, 11. 0.909. And next, the third condition is k is equal to, k is equal to 1000 and h is equal to 1. Have to use this condition. So c by r is 1000 by 1001. For the second case, I will get the answer 0.909. Third case, 0.999, that is almost equal to 1. Approximately equal to 1. Now this is the very good answer. If we increase the value further and further, that is kg is increased, at that time the forward path does not affect the system output. So what is the answer? That is very large is a correct answer. Next problem. The block diagram shown in figure is to be represented as in figure B. Figure A, that is reduced representation in figure B. What is the value of h of s? Here in this block diagram, it consists of 3 blocks, 2 forward block and 1 block that is connected to the parallel block. Okay, that is 2. Now, our aim is to find out the height of S. Already we got the answer 10 divided by S in the S plus 1. So, these two are combined together. Both are combined together. So, we will get the answer. So, what we have to do? I am going to change the takeoff point, move the takeoff point that is ahead of the block. So what I have to do, I have to divide 2 by 1 by S. So this is the new block diagram. So 10 by S in the S plus 1 into 1 by S. Both are connected in series. I will get 10 by S in the S plus 1. Then move ahead of the block. So 2 divided by 1 by S. And here the gain is 1. So both are is connected in parallel. So parallel means I have to add both 2s plus 1. So option A is the correct answer. Next problem. For the system shown in figure with the damping ratio zeta for 0.7 and the undamped natural frequency omega n 4 radians per second. The value of K and A are. Here G of S is given and H of S is given. G of S is K divided by S into S plus 2. H of S is 1 plus AS. How to find out the transfer function? So this is the equation used to find out the negative feedback loop, reduction of negative feedback loop. G of S divided by 1 plus G of S into H of S. What is C of S divided by R of S? Have to put the G of S, K divided by S into S plus 2 and divided by 1 plus K by S into S plus 2 into H of S. And K, here I have to take the LCM. So S into S plus 2 plus K into 1 plus AS divided by S into S plus 2. So with the terms in the numerator S into S plus 2 both are cancelled. And final answer K divided by S square plus 2S plus K plus AKS. K divided by S square 2 plus AK into S plus K. Compare this with the standard second order transfer function. That is C of S divided by R of S equal to omega n square divided by S square plus 2 zeta omega n S plus omega n square. Here, what is omega n square? Compare both omega n square equal to K. Already omega n is known value. So first we have to find out the value K. K is omega n square, that is 16. And next take the second term, coefficient of S, 2 zeta omega n, that is equal to 2 plus AK. Both are equated together. So 2 plus A into 16, already 16 is a known value. That is 2 into 0.7 into 4. From this what is A? 5.6 minus 2 by 16. 3.6 by 16, that is equal to 0.225. So the answer C is option C is the correct answer. Next problem. Which of the following is an example of open loop system? Household refrigerator. It is not an open loop system. And respiratory system of a human. That is closed loop system. Stabilization of air pressure entering into the mask is also closed loop system. But only one open loop system is execution of the program by a computer. Whatever program we have to give, we'll get an output. And next, if the unit step response of a system is a unit impulse function, then the transfer function of the such system will be unit step response of the system is unit impulse function. So unit impulse function is del of t. So what is L of del of t? L of del of t is equal to 1. And what is unit step response? L of u of t, that is equal to 1 by s. So 1 by s is the input and output is the 1. What is the transfer function? H of S. Output 1 divided by input. 1 by S, that is equal to S. Option B is the correct answer. Next problem, the open loop transfer function of a unity feedback control system is given by G of S is equal to K into S plus 2 divided by S into S square plus 2S plus 2. The centroid and angles of root locus asymptote are respectively. Here I am going to find out centroid and asymptote. Before I finding out the centroid and asymptote, first of all I should know how many poles and zeros available. So poles means denominator equation equal to 0 to get the poles and numerator equation is equal to 0 to get the zeros. So S is equal to minus 2, only 1 0. And denominator, how many poles? S is equal to 0, one of the pole, and remaining poles are S square plus 2S plus 2 equal to 0. Here I have to use minus B plus or minus square root of B square minus 4AC by 2A minus 2 plus or minus square root of 2 square minus 4 into A is 1, C is 2. 4 into 2, 8 divided by 2. Minus 2 plus or minus square root of minus 4, that is J2 divided by 2. So minus 1 plus or minus J. So 3 poles are in the denominator. Next I am going to explain how to find out the centroid. How to find out the centroid? Sum of poles minus sum of 0 divided by number of poles minus number of 0. Here 3 poles are there. So first one is 0. Then the next pole is minus 1 plus j and another one minus 1 minus j minus of minus 2 is the 0. Divided by number of poles are 1, 2 and 3. 3 numbers of poles and only 1 0. 3 minus 1 equal to 2. That is 0 by 2, that is equal to 0. And next I am going to explain how to find the asymptote angle. The formula used is plus or minus 2q plus 1 into pi divided by n minus m, number of poles minus number of zeros. How to find out the q value? Q value that starts from 0 and ends at n minus m minus 1. N is number of poles 3, number of zeros 1 and minus 1. So 0, 1, that is the values of q. First substitute q is equal to 0. So it is a1 2 into 0 plus 1 divided by 2 into 5. So that is equal to 2 into 0. 0 plus 1, 5 by 2. That is the first answer. Second, substitute q equal to 1. What is A2 asymptote angle 2 is 2 into 1 plus 1, 3. 3 by 2 into pi. That is equal to 270 degree. How to write the 270 degree? 270 is the plus 270 or we can write minus 90 degree. See, this is positive angle and this is the negative angle. So this is equal to 90, 190, 270 or otherwise I have to write minus 90. Clockwise negative angle, anti-clockwise positive angle. Next problem. The transmittance from x to y in the signal flow graph shown in figure is. What is the equation for transmittance? Summation pk delta k divided by delta. So this is the equation. What is pk? Forward path. Del k is equal to delta, but the loop is not touching in the kth forward path. First of all, I am going to find out how many forward paths? So the forward paths are that start from input and end at output, all are known as forward path. The first forward path is x to y is 1 and the second forward path is x to y, that is 1. P2 is 1. And next find out the loop. Only one self loop is available, that is L1 equal to minus 2. Now I am going to expand this equation. So P1 delta 1 plus P2 delta 2 divided by delta. This is the expansion. I have to substitute the value P1. What is delta 1? Here only one loop is there that touches both forward path. So delta 1 equal to 1 minus 0. Delta 2 also 1 minus 0, 1 plus 1 divided by 1 minus sum of integer loop. Only one loop is available, that is minus 2. 1 minus of minus 2, that is plus 2. 2 divided by 3 is the correct answer. So which option is correct? Option number 3 is the correct answer. Next problem. The transmittance from A to B in the signal flow graph shown in figure. Here also the formula is summation Pk delta K divided by delta. First I am going to find out number of forward path. So forward path is the signal starts from input and ends at the output, that is forward path. Then find out the number of loops. Here only one loop is there, AB minus 1. So only one loop. The gain of the loop is minus AB. And next find out the transmittance. P1 delta 1 divided by 1 minus of L1. A divided by 1 minus of minus AB, that is 1 plus AB. Option A is the correct answer. Next problem. Problem number 24. Consider the following signal flow graph which have the same transfer function would include. See the first one. What is the forward path? K1 into K2. Only one feed loop is available, self loop. 1 minus K3. Okay, next find out the second one. T is equal to forward path K1, K2. And loop is K2, K3. 1 minus K2, K3. And next the third one. K1, K2 is the forward path. And the loop is K1, K3. And the fourth one, K1, K2 is the forward path and only one self loop, that is K3. K1, K2 divided by 1 minus K3. See the equation 1 and 4, both are correct. So option B is the correct answer. Next, for the signal flow graph shown below, the transmittance between x2 and x1 is. So this is the signal flow graph. As I have told the previous problem, the formula is summation Pk delta K divided by delta. First one is find out the forward path. Here the forward path is the signal starts from the input and ends at the output. The input is x1 and output is x2. So first one is Rs into U. That is the first forward path. And next second forward path. See, this is the second forward path. EFH. Second forward path over. Then feedback loop. The loop number 1. So first loop is, you see the loop is S into T. This is the loop number 1. And what is the second loop? The second loop is F into G. This is the second loop, F into G. And next I am going to find out the non-touching loop. Here both the loops are not touching. Both loops are considered as a non-touching loop. Multiply this gain of this loop, we get the gain of the non-touching loop ST in the FG. And next I am going to find out the transmittance T. P1 delta 1 plus P2 delta 2 divided by 1 minus sum of individual loop gain plus sum of gain product of two non-touching loop. So first I am going to write P1. P1 is RSU into 1 minus the loop that is not touching in the kth forward path. Delta 1 formula is same as the delta, but the loop is not touching in the kth forward path, that is taken into account. So 1 minus FG plus EFH, second forward path EFH, into 1 minus ST. That is also correct. Divided by 1 minus sum of individual loop. One is ST and another one is FG. 1 minus ST minus FG, sum of gain product of non-touching loop ST FG. And next RSU into 1 minus FG plus EFH into 1 minus ST. Then I have to divide the denominator terms 1 minus ST into 1 minus FG. Now I have to divide the two terms. The first term is divided by these two terms in the denominator. Both should be cancelled. RSU by 1 minus ST. And second plus EFH divided by 1 minus FG. 1 minus ST cancelled. So 1 minus FG. That's all. So the option A is the correct answer for this problem. And next problem. The signal flow graph of a closed loop system is shown in figure, where TD represents the disturbance in the forward path. The effect of disturbance can be reduced by, see, I am going to find out C of S divided by TD of S. TD of S is the disturbance. So, plus 1 divided by 1 minus G1, G2 into H1. Okay. And C represent the 1 minus here plus, 1 plus G1, G2 into H1. And the effect of disturbance can be reduced by the effect of disturbance C of S into TDS. The effect of disturbance can be reduced by increasing the value. So increasing the denominator means, what about C of S divided by TD of S? TD of S should be decreased. Okay, increasing the denominator, the total value should be decreased. That's all. So increasing the G1 of S, that is the correct answer. Next problem. In the signal flow graph shown in the figure, the correct relationship between the various variables are. See here, W is there. I am going to write W equal to, what are the signals meeting in the W point? The first signal is C, C into Y. And second, B into X. And A into U. So both the answers are correct answers. B and C, both are correct answers. And next problem. The transmittance from A to B in the signal flow graph shown in figure. Okay, here we have to find out the transmittance. What is the formula? That is summation k is equal to 1 to n pk delta k divided by delta. First I am going to find out number of forward paths in the signal flow graph. Forward path starts from the input and ends at the output. Start from the point A. So P1 is 1 into 1 into 1, that is 1. And next I am going to find out number of loops. There are two loops available. One of the loop 1 into minus 1. What is the second loop? Second loop is 1 into minus 1. So two loops are there. Okay, after finishing this, I am going to find out the transmittance. P1 delta 1, have to expand this, divided by 1 minus sum of individual loop. So P1 is equal to 1. And what about delta 1? Here both the loops are touching in a kth forward, first forward path. So 1 minus 0. And next 1 minus of minus 1 minus 1. So the answer is 1 by 3. That is option D is the correct answer. Next, problem number 29. If the intermediate variable C in the signal flow graph shown in the figure has the value 10, the input A has a value. So C value is given here. Have to mark the C value here. So up to C only I am going to find out the output. So what is C by A? C by A is the transfer function summation Pk delta K divided by delta. So forward path is the first forward path, that is A to A, B, C. So P1 equal to 1 into 1. P1 is 1. And next find out the loop. Loops are how many loops? Here this is the loop number 1. So 1 into minus 1. And see, this is the second loop. 1 into minus 1. And next find out the loop. This is also the third loop. And this is fourth loop. In this way we are having 4 numbers of loops are available. And next, after finishing this, find out the transmittance. So transmittance is P1 delta 1 divided by 1 minus sum of individual loop gains. 1 into 1 minus of minus 1. Here see, this is the forward path. This loop is not touching in the forward path. So this loop gain is taken into account. So 1 minus of minus 1 divided by 1 minus of minus 1 minus 1 minus 1 and minus 1. So C by A equal to 2 divided by 5. So already we know the value of what? Value of C. C is known. So here find out A. A is C into 5 divided by 2. What is C? C is 10. So 10 by 2 into 5. What is the answer A? A is the answer 25. Option B is the correct answer. And next problem number 30. The transfer function V of S divided by I of S in the signal flow graph is shown in figure. So see, in the transfer function also I am going to find out the transmittance or transfer function. V of S divided by I of S. Pk delta K divided by delta. So first find out the forward path. So this is the forward path, that is S. Here two self loop in the same node. So one of the loop is minus S and the second loop is minus 1 by S. How to find the transfer function? S into delta 1, no, 1 minus 0 divided by 1 minus of minus S, sum of integer loop minus S minus 1 by S. Now S divided by 1 plus S plus 1 by S. Take LCM here, S divided by S plus S square plus 1 by S. S multiplied together, S square divided by S square plus 1. So option A is the correct answer. Next problem, the solution set for the variable x, y in the signal flow graph shown in the figure below. Here the signal flow graph is given. Here find out x and y. So what is x? X is equal to minus 2x. So from this 3x equal to 0. This is self loop. 3x equal to 0 and x is equal to 0. In the similar manner, y is equal to, here x into 1. So x minus y. So 2y equal to x and y is equal to 0. The option x equal to 0 and y is equal to 0 is the correct answer. Next, the condition of the stability for a unity feedback control system whose open loop transfer function is given by g of s is equal to e power minus st divided by s into s plus 2. First of all, I am going to write what is e power minus st. That is 1 minus st by 1 factorial plus st the whole square by 2 factorial and so on. Then I have to write the characteristic equation. Characteristic equation is 1 plus g of s into h of s equal to 0. H of s equal to 1. So put the value g of s. E power minus st capital T divided by s into s plus 2. Next I have to cross multiply this s into s plus 2, that is s square plus 2s plus 1. Here first two terms only have to take, neglect the higher order terms. 1 minus st equal to 0. S square plus 2 minus t into s plus 1 equal to 0. Next, stability is determined by root stability criterion. So first put s square, then s power 0. S square, the coefficient of s square 1, coefficient of s power 0 1, 1, 1. Then coefficient of s, put it here, 2 minus t and 1. Here what is the condition for root stability criterion? The first column of the root array should be positive. So 2 minus t, that should be greater than 0. So t is less than 2. So the condition is t is less than 2. Next, consider the following overall transfer function for the unity feedback system 4 divided by s square plus 4s plus 1. Which of the following statement regarding the system are correct? The first one given is position error constant Kp for the system is 4. First of all, I am going to find out Kp. Kp is limit s tends to 0 into g of s into h of s. Limit s tends to 0, h of s is 1. So g of s is 4 divided by s square plus 4s plus 1. Puts 0 for s. So 4 divided by 1, the value equal to 4. So Kp equal to 4, this answer is correct. And next, the system type 1. Here, type means the separate S or pole at the origin. There is no pole at the origin, so this is wrong. And third, the velocity error constant Kb for the system is finite. Kb equal to limit s tends to 0, s into g of s. Have to put s here, s into g of s is 4 divided by s square plus 4s plus 1. So you put s is equal to 0, remaining term should be 0. The velocity error constant is the system is finite, it's not infinite. So the option D is the correct answer. Next, when two identical first order systems have been cascaded non-interactively, the unit step response of the systems will be critically damped. That is the correct answer. Next, problem number 35. Here the signal flow graph is given. Calculate C by R. So first of all, you have to calculate the forward path. Forward path, the signal start from input and insert the output. Forward path is G. And we are having two individual loops. One of the loop, that is self loop, minus H1, then minus H2. So H1 and then this is H2. And both are non-touching loops, so multiply the gain of non-touching loop H1, H2. Then find out C by R. C by R is forward path P1 into delta 1 is 1 divided by 1 minus of individual loop gain minus H1 minus H2 plus H1 into H2, sum of gain product of non-touching loops, and G divided by 1 plus H1 plus H2 plus H1 H2. So how we can write G divided by 1 plus H1 into 1 plus H2. So the option C is the correct answer. Next problem, a linear second order system with a transfer function G of S is equal to 49 divided by S square plus 8S plus 49 is initially at rest and is subject to a step input signal. The response of the system will exhibit a peak overshoot of. Here I am going to find out the peak overshoot. So what is the formula for peak overshoot? MP equal to e power minus delta pi divided theta pi divided by square root of 1 minus theta square into 100. So this is the formula used to find out maximum or peak overshoot. The quantities required is zeta only. So for finding out zeta, first of all I am going to find out omega n. For finding out omega n, I have to write the general second order transfer function. Omega n square divided by s square plus 2 zeta omega ns plus omega n square. Now compare both. So omega n is equated to 49. So omega n square equal to 49. Omega n is 7 radians per second. Then zeta. Take the second term. 2 zeta omega n is equated to 8. 2 zeta omega n equal to 8. Zeta equal to 4 divided by 7, that is 0.57. Next I have to substitute the value here, minus 0.57 into 3.14, the whole divided by square root of 1 minus 0.57 square into 100. So if you multiply and using the calculator, I'll get the answer 2%. So option C is the correct answer. Next problem, consider the following statement regarding time domain analysis of a control system. The first one, derivative control improves system's transient performance. That is correct. Integral control does not improve system's steady state performance. But the answer is integral control improves system's steady state performance, so it is wrong. Third, integral control can convert a second order system into third order system because integral means 1 by s. Already order, second order is there means this multiplied with this, it will increase the order of the system to third. Okay, so 1 and 3 is the correct answer. Next, the principle of homogeneity and the superposition are applied to linear time invariant systems only. Next, match list 1 and 2. Select the correct answer using the code in the given list. So first A, B, C, A, B, D, first forward path. Then A, C, D, second forward path. So 1, the answer is A, B, D plus A, C, D, 2. A is 2. And next B, the forward path is A, C, the forward path. Then A, D, the second forward path. B, C, third forward path. B, D, fourth forward path. So that is 1. Second one is 1. So B is 1. Then C. The forward path is A, C. AC is the forward path. Then A, D plus AD forward path. Then loop. Loop is A into B. Only one loop is available, 1 minus AB. So C is equal to AC plus AD divided by 1 minus AB 4. And next D. In the D, AC forward path. Then BC, the next forward path. So loop is C into D, not BD, C into D. 1 minus CD. Okay, so that is the D is 3, C is 4 and D is 3. So 2, 1, 4, 3 is the correct answer. Option D is the correct answer. Next, match list 1 with list 2 and select the correct answer using the codes given below in the list. So first take 1 divided by s plus alpha plus into s plus beta. Can we write like this? Using partial fraction, we can write the initial step as a by s plus alpha plus b by s plus beta. So how to write this? A into e power minus alpha t plus e power b into e power minus beta t. Here, this is the decreasing exponential. So, a is equal to 3, a to 3, decreasing exponential. And second, 1 divided by s minus alpha into s minus beta. So, I use a partial fraction. I have to divide it a by s minus alpha plus b by s minus beta. And write like this, a into e power alpha t plus b into e power beta t. So this is the increasing exponential function. So b is equal to 1. And next C. C is 1 by s minus alpha plus j beta. S minus alpha minus j beta. First of all, have to use this. Have to use the formula a plus b into a minus b. So, s minus alpha the whole square plus beta square. jb minus j square. So, minus 1. So, plus beta square. So, it is similarly as the sine and exponential. It is a combination of sine and exponential. What is sine? Sine beta t is a square plus beta square. But there is no beta term is available. So, I have to multiply and divide it with beta. So, 1 by beta into e power minus alpha t into sine beta t. So, the waveform is the sine waveform, but the exponential is the increasing exponential. Increasing exponential sine. So, here 2. C is 2. And next D is also we can write like this, but e power minus alpha t. So this is the decreasing exponential. D is equal to 4. So option 4 is the, B is the correct answer. Next problem number 16. Match list 1 with list 2 and select the correct code given below. So first, time function e power minus 2t into t minus 2. First of all, I am going to apply the Laplace transformation. So what is the Laplace transformation of e power minus 2t? That is 1 by s plus 2. And here some delay is there, t power t minus 2, that is represented as e power minus 2s in the Laplace transformation. So a is equal to 2. Next, d by dt of t square. First of all, I have to apply the differentiation. What is the differentiation of t square? That is 2t. Then apply the Laplace transformation. L of 2t is 2 divided by s square because t power n is s power n plus 1 divided by n factorial. N factorial divided by s power n plus 1. So that is the formula. So t power 1 is 1 factorial divided by s power 1 plus 2, that is 1 plus 1, 2. So L of 2t equal to 2 by s square. And then t by 2. What is the Laplace transformation of t by 2? 1 by 2 into 1 by s square. So 1 by 2s square. So first one is 2, second 1, third 3. Option A is the correct answer. Next problem, problem number 17. The unit impulse response of a system is given as f of t is equal to minus 4 e power minus 2t minus plus 6 e power minus 2t. The response of the same system for t greater than or equal to 0. So first of all I have to take f of t is minus 4 e power minus t plus 6 e power minus 2t. Then I am going to apply the integration here. So you have to integrate the impulse response. We get the next response, that is the step response. Here the impulse response is here, but they have asked about the step response. So I have to integrate this. So apply the integration, minus 4 into e power minus t divided by minus 1. The limits are t greater than 0, 0 to t, plus 6 into e power minus 2t divided by minus 2, the integration limit 0 to t. Next 4 into minus plus 4 into e power minus t minus e power 0, that is minus 4, plus 6 into e power 6 minus 2. Okay, then e power minus 2t minus e power 0. So that is minus 3 e power minus 2t. Here e power 0 is 1. So plus 3. First write minus 3 e power minus 2t. Next write 4 e power minus t. Then minus 4 plus 3, that is equal to minus 1. And next problem. A system with characteristic equation s power 4 plus 2s cube plus 11s square plus 18s plus 18 equal to 0, which have closed loopholes such that. Here, this characteristic equation is stable or not, that is find out by means of Routh stability criterion or H criterion. First is write S4, then S cube, S square, S power 1 and S power 0. Write the coefficient of S power 4, then S square, then S power 0. And for the next one, for S cube and coefficient of S power 1. And next, how to find out this? Here multiply 2 into 11 minus 18 by 2. That is equal to 2. 4 by 2. Then 2 into 18. Here 0 into 1. Again divided by 2. 36 minus 0 by 2, 18. See 2, 18. Here also 2, 18. Cross multiply this. So first you have to multiply this. So 2 into 18 minus 2 into 18 divided by 2. That is 0. Again 0. 0 is the first column of the Routh array. So this characteristic equation that consists of imaginary terms. Two poles lie symmetrically on the imaginary axis. 0 is the first column of s power 1. So we can say that the system is unstable and two poles lie symmetrically on the imaginary axis of the S-plane. Option C is the correct answer. Next problem. For the network given in figure, V1 of t is the input and I of t is the output. The transfer function I of s divided by Vi of s of the network is. This network is simple RLC series network. The supply given is Vi of t and the current flowing through this I of t. First of all, I am going to write the voltage equation. So Vi of t is Ri of t plus L into di of t divided by dt plus 1 by c into integration I of t dt. Apply the Laplace transformation. V I of s is equal to R into I of s plus L into s into I of s plus 1 by cs into I of s. Next, Vi of s, take I of s as common. So, inside R plus Ls plus 1 by Cs. Have to take the LCM. Vi of s is I of s into R into C of s plus L into C into s square plus 1 the whole divided by Cs. What is I of s divided by Vi of s? I of s divided by Vi of s is Cs divided by Lc into s square plus Rc into s plus 1. So option A is the correct answer. Next problem, a control system whose step responses is minus 0.5 into 1 plus e power minus 2t and u of t is cascaded to another control block whose impulse response is e power minus t. The transfer function of the cascade combination. Here one of the response given is step response and another one response given is impulse response. Okay, first of all what we have to do, both are connected in cascade, that is in series. So first of all we have to convert step response into impulse response or impulse response into step response, then I have to proceed the problem. Here what I have to do, first of all I have to convert the given step response to impulse response. How to find out step response to impulse response? By taking differentiation. So differentiation, the higher should be come into a lower one. So first of all I have to apply the differentiation of the step response. D by dt of minus 0.5 into 1 plus e power minus 2t and that is equal to minus 0.5 into minus 2 into e power minus 2t. 2 into minus 5, that gives the value 1 into e power minus 2t. Now the step response is converted into the impulse response. After finishing this, what I have to do, have to cascade the block. First step response and second one is this is step and this one is impulse response. Then what I have to do, have to apply the Laplace transformation of the step response and the impulse response. The step response for e power minus 2t is 1 by s plus 2 and step here Laplace transformation of e power minus t is 1 by s plus 1. The answer is 1 by s plus 1 into s plus 2. Option A is the correct answer. Next, the error response of a second order system to step input is obtained as E of t is 1.66 into e power minus 80 into sine 60 plus 37 degree. The damping ratio, so it's equated to the standard second order response. C of t is e power minus delta omega n into t divided by 1 minus delta square into sine omega d plus theta. From this, I have to compare this minus 8 equal to zeta omega n. Zeta omega n is 8 and omega n square root of 1 minus zeta square. Omega n square root of 1 minus zeta square or omega d, that is equal to 6. So this is the equation number 1, equation number 2. Divide 1 by 2. Zeta divided by square root of 1 minus zeta square, that is 4 divided by 3. Taking square on both sides of the equation, 1 minus zeta square, just invert this, 1 minus zeta square by zeta square, that is equal to 9 divided by 16. Then cross multiply this, 16 minus 16 zeta square equal to 9 zeta square. So add both, 16 plus 9, 25 zeta square equal to 16, zeta equal to 4 divided by 5, that is equal to 0.8. Option C is the correct answer. Next problem, in a linear system, an input 5 sin omega t produces an output 10 cos omega t. The output corresponding to input 10 cos omega t will be equal to. So 5 sin omega t, that produce the value 10 cos omega t. So here differentiation of sin omega t is cos. So what is the operator used? That is the differentiator. And what about the omega? Omega equal to 10. Already we are having the magnitude 5. Now it will be changed into 10. So the multiplication of omega, that is 2. Okay, here what is given? 10 cos omega t is given. So the same operator is used. So apply the differentiation, 10 into minus sin omega t, correct? Minus 10 into sin omega t into omega. The omega equal to 2. So minus 10 into 2, that is minus 20 into sin omega t. So that is the correct answer. So which one is correct? Minus 20 sin omega t. Option D is the correct answer. Next, as compared to the closed loop system, an open loop system is more stable and less accurate than the closed loop system. Option C is the correct answer. Next, consider the following statements regarding time domain analysis of control system. The first one, derivative control improves system's transient performance. That is correct. And next, integral control does not improve system steady state performance. That is wrong, because integral control improves system steady state performance. The next one is integral control can convert a system second order system to third order system. So order is increased by using integral control. So the option 1 and 3 are correct. That are the correct. Next problem, consider a system shown in given figure. U of S, 2 by S is a block and C of S. If the system is disturbed so that C not equal to 1, then C of T for the unit step input will be. What is C of S by U of S? That is the transfer function. So that is equal to 2 by S. What is U of S? U is the unit step input. U of S is equal to 1 by S. So I have to substitute the value. So 2 by S square. If you take the inverse Laplace transformation, we get 2t. In the initial time, it is disturbed by the C of 0. So what is the final value? 2t plus 1. So 2t plus 1 or 1 plus 2t, that is the correct answer. Next problem. By a suitable choice of scalar parameter k, the system shown in the figure below can be made to oscillate continuously at the frequency of 1 radians per second, 2 radians per second, 4 radians per second, and 8 radians per second. First of all, I am going to find out the characteristic equation. That is 1 plus g of s into h of s is equal to 0. H of s is the unity feedback system. Always h of s is equal to 1. 1 plus k divided by s into s plus 2 into s plus 8 equal to 0. Okay, plus s into s plus 2 into s plus 8 equal to 0. Now have to find out the expansion of this. K plus s cube plus 10s square plus 16s equal to 0. Put s is equal to j omega. K plus j minus j omega cube minus 10 omega square, because s is equal to j omega, j square omega square, minus 10 omega square plus 16 j omega equal to 0. K minus 10 omega square is the real value, and imaginary term omega cube minus 16 omega equal to 0. Hence, for system oscillation, omega cube imaginary component equal to 0. Omega cube minus 16 omega equal to 0. So omega square minus 16 is equal to 0. Omega equal to plus or minus 4 radians per second. So 4 positive value have to take. So 4 radians per second is the correct answer. Next problem. The open loop transfer function with unity feedback are given below for different systems. The first system g of s is equal to 2 by s plus 2. Here have to apply the root stability criterion. For the applying the root stability criterion, first of all forming the characteristic equation 1 plus g h equal to 0. So 1 plus 2 by s plus 2 into h equal to 0. So s plus 2 plus 2 s plus 4 equal to 0. Next apply the root stability criterion s power 0, 1 and 4. So both are positive. So here all the roots are in the left half of the S plane. So the system is stable. And next 1 plus 2 by S square plus 2S equal to 0. S square plus 2S plus 2 equal to 0. Apply the RH criterion. S square S power 0. 1, 2, 2. 2 into 2, 4. 4 minus 0. That is 4 by 2. Here that is not 3 by 2, 4 by 2, that is 2. Next, the third one, g of s is equal to 2 divided by s square into s plus 2, s square into s plus 2, that is s cube, 2s square plus 2 equal to 0. There is one term is missing, that is the coefficient of s and s term is missing. So we can say the system is unstable. Option C is the correct answer. Next, for a constant k, the phase lead compensator reduces the slope of the magnitude curve in the entire range of frequency domain is the correct answer. Constant k. K is constant so that it reduces the slope. Next problem, consider the following statement with reference to the phase lead compensator. Phase lead compensator that increases the margin of stability and speeds up the transient response, both are correct, does not affect the system error constant. So that is wrong. So B is the correct answer. 1, 2 are correct. Next, for a feedback control system of type 2, the steady state error for ramp input. First of all, have to write the type 2 system example k by s square into s plus 1. ESS is equal to 1 by kV. What is kV? Limit s tends to 0, s into g of s, limit s tends to 0, k divided by s into k divided by s square plus into s plus 1. S cancel and we get the answer k divided by s into s plus 1. Put 0 here. What will get? K by 0, that is infinite. And what is ESS? ESS is inverse of kV, 1 by infinite, that is equal to 0 is the correct answer. Thank you. Have a nice day.